Hey guys, today we're going to do Chapter 6, Lesson 3, Accumulation Functions. I think you're going to find a pattern as you see some of the notes that we are going through today. So we're looking at the fundamental theorem of calculus, and we'll look at that into more detail. But basically what it says is you are going to plug your bounds into your antiderivative to get a functional value. So what we're going to do here on problem number 1 is we are going to do the area. And g of x is going to be from -6 to x, which will be these values you see here in parentheses. And then we're going to evaluate. So g of -3 is from -6 to -3. And as you can see, that does not create a figure that we can find the area of easily. But if we draw a line right here from -6 to -4, we have a trapezoid. From -4 to -3, we have a trapezoid. So we can add the two trapezoid areas together to get g of -3. So here we're going to have 1/2 times the height times the sum of the bases. 1, 2, 3. And that should be 4. So 4 is the area of the first piece. And then for that second trapezoid, we have 1/2 the height times the sum of the bases. 1, 2, 1, 2.5. Looks like, and 1, 2, 3. So 3 plus, I think that's about 2.5. So let's see, 5.5 divided by 2 is 2.75. So that's our area here. So the answer is 4 plus 2.75, which is 6.75. And you're going to do that throughout the rest of the graph. Now, the accumulation function comes in is from -6. It's always going to start at -6, and it's going to go up until this value that you see here. So we're going to go to 0 next, and that's another trapezoid that we're going to find the area of. And we're going to add those three together. So 1/2 times 1, 2, 3, the height, times the sum of the bases. 1 plus, I think we said that was 2.5. So 3/2 times 3.5 is 5.25. So g of 0 is the area from -6 to 0, from -6 to 0. So 4 plus 2.75 plus 5.25, add all those up and you get 12. G of 4, luckily we can do one figure there. So we said that was 5.25. 1/2 the height, 1, 2, 3, 4, times the sum of the bases, 1 plus 1, 2, 3, 4, 5. 2 times 6 is 12. So G of 4 would be 4 plus 2.75 plus 5.25 plus 12, which is 24. Notice it's just 12 plus the last number, 12, which is 24. And then over to 7, we have another trapezoid. So 1/2 the height, 1, 2, 3, times the sum of the bases, 1 plus 1, 2, 3, 5. So that would be 6. 6 divided by 2 is 3, and 3 times 3 is 9. So 4 plus 2.75 plus 5.25 plus 12 plus 9 is 33. But notice, like I said, g of 0 is just g of -3 plus this next piece, and g of 4 is -6 to 0 plus this next piece, and g of 7 is -6 to 4 plus this next piece. So that's where your accumulation comes in. You're adding from what you found prior. Taking a look at example number 2, we're going to do the same thing here. What I want you to notice is when the lower and the upper bounds are the same, when the upper and the lower bounds are the same, the area is 0. You can't find the area of a point. All right, so now we're going to go to 1. The area there is 2. 1 times 2. And then so the integral from 0 to 1 is just 2. Then here we have a trapezoid. So area, I'm just going to have my calculator handy. Area is 1/2 times the height, 1 times the sum of the bases, 2 plus 1, 2, 3, 4. And that's 3. And then this is a triangle, so 1/2 times the base, which is 1, times the height, which is 4. And that's 2. Now I'm going to draw a triangle here and find that big space. I think we'll be okay there since it goes straight from 3 to 6. So that's 1/2 times the base of 2 times the height of 2, which is 2 in a negative direction. And then 2 times 1 is 2 in a negative direction. And then 1/2 times 1 times -2 is just -1. So if they're below the x-axis, they're going to have a negative value. If they're above the x-axis, they'll have a positive value. So g of 2 goes from 0 to 2. From 0 to 2 is 2 plus 3, which is 5. G of 3 is 0 to 3. 2 plus 2 is 4. 4 plus 3 is 7. Excuse me, G of 6 is 0 to 6. So 2 plus 3 plus 2 minus 2 minus 2. 2's cancel, so you get 3. And then G of 7 is 0 to 7. And 3 minus 1 is 2. Excuse me. So you're going to plot the points on G of x. That's the graph you see here. 0, 0, 1, 2, 2, 5, 3, 7, 6, 3, and 7, 2. And if you can't see where those points come from, it's 0, 0, 1, 2, 2, 5, 3, 7, 6, 3, and 7, 2. So we're going to plot those on our graph. 0, 0, 1, 2, 2, 5, 3, 7, 6, 3, and 7, 2. So you can kind of see what your graph is going to look like there. Connect your dots. You can see you're going to have a slight curve before you start to come back down and then stop. So on what interval is g of x increasing? It's increasing from 0 to 3. So g of x increases where g prime of x is greater than 0. And this is on 0 to 3. And where does g have a maximum value? Well, obviously on our graph, it's 3, 7. But what if you didn't have a graph? You look at your output. Biggest number is 7, so that was your maximum. So g of x has a maximum value where f changes sign from positive to negative, positive to negative, which is at x equals 3. The max is 7. So you have a couple of different things that you can look at in order to do that. And then part D says sketch the graph, and we've already done that as well. You may want a piece of notebook paper. Example 4 is going to require that. Example 3, we can just use what we have right here. So complete the table of values for the function f. So we're starting at 0, which is very nice. And we're going 0, 1, 2, 3, 4. And then we actually need to extend this chart. and include 5, 6, 7, 8, and 10. Another accumulation function that we have here. So we're looking at our graph that you see here. And at 0, we have no area. So we are at 0. 0 to 0 is no area. All right, at 1, 1/2 times 1 times 1 is 1/2. At 2, so we've got, let's just look at it and see if we can do our triangle here. 1/2 times 2 times 2 is just going to be 2. And we've included that 1/2 in that particular function. 3, we can do the same thing. So we can do the accumulation function and find 2 trapezoids plus a triangle, or we can just do one big triangle. So 1/2 times 3 times 3 is 4.5. And you're welcome to write that out to the side. This is 1/2 times 3 times 3. And 4, another triangle. 1/2 times 4 times 4 is 8. It's going to start getting maybe a little bit different here because when I go to 5, I'm going to have to do the 4 plus the 5 as a trapezoid. So 0 to 4 is 8 plus the trapezoid, which is 1/2 times the height times the sum of the bases, which gives me 11. And then for 6, you have one big triangle. So 1/2 times 6 times 4 is 12. Then we're going to 7. It's negative. It's below the x-axis. So that's a little triangle, 1/2 base times height. So we're going to do 12 minus 1/2 times 1 times 1. 12 minus 1/2 is 11.5. And then 8, we have another triangle here, which will also be negative. So I'm going to do the big triangle. So I'm going to do 12 minus 1/2 times the base times the height. 12 minus 3 is 9. And then this triangle that you see here, do the big triangle. 12 minus 1/2 times 4 times 3 is 6. So there are multiple ways that you can figure that out. The accumulation function will work the whole time, or you can use it part of the time. So our domain is from 0 to 10. It is including those values. Plot the area accumulation to complete the graph of f. Plot your points on your table in blue. All right, so 0, 0, 1, 1/2, 2, 2, 3, 4.5, 4, 8, 5, 11, 6, 12, 7 is 11.5, 8 is 9, and 10 is 6. Just connect the dots of your curve. And that's f of x. So where is the 0 of f? At 0. Remember, 0 is a curve where the upper and lower bounds are the same. The total change in f is f of 10 minus f of 0. So 6 minus 0 is 6. How does the total change in f compare to the net area bounded by the graph of the function f and the x-axis? They are the same. Remember, your area and your displacement are the same. What is the maximum value of f? Your largest value is 12. And this occurs at the point 6, 12. So at x equals 6. And what is the range of f? The smallest value to the largest value is 0 to 12. All right, so here's where you're going to need your notebook paper. So we are looking at the function now, g of x equals 3 to x f of t, and that's going to change some things up for you. So making sure you have some notebook paper. You guys will be able to see your graph at the same time that I am working here. This is problem number 4. We're going to start by finding g of 0. So what we're going to do out to the side, just like we did on the other paper, is we're going to create, or excuse me, on the other example, we're going to create a chart x and g of x. And then once we create that chart, answering these questions should be pretty easy. Now this one's pretty simple. Where is the 0 of g? The 0 occurs where the top and the bottom are equal, so that's at x equals 3. So we know in our chart we should get 3, 0. And g of 0 is the first one we're going to find, so we should be able to fill that in fairly quickly as well. So g of 0 is the integral from 3 to 0 of f of t dt. Now, when your upper and lower bounds are backwards, in other words, the smaller one is on top, you put a negative out front and you correct them. So the integral from 0 to 3, which we found in the upper part, we said was 4.5. 0 to 3 was 4.5. So this one is negative because your bounds were switched. So 0, negative 4.5. G of 0 is negative 4.5. The domain of G is going to be the same as F. We're still working 0 to 10. And now we have to do the total change. This is where it takes just a minute to fill these in. I'm going to do a few, and then I'm going to pause the video, and then I'm going to give you a chance to look at the rest, because there's no need for me to take all of this time to show you how to do them if you understand what you're doing. So now we're going to do G of 1, integral from 3 to 1, f of t dt equals negative integral from 1 to 3 of f of t dt. Now, keep in mind we're looking from 1 to 3. So from 1 to 3, and we're looking at 1 to 3 with that original function. And I'm going to highlight that so that that's easier for you guys to see. So we're looking at the original function when we're finding these values, the original function, not the curves. Okay. All right, so in order to find that, we have a trapezoid. We have the negative out front, 1/2 times 2 times 1 plus 3, which is negative 4. G of 2, integral from 3 to 2 of f of t dt is the negative integral from 2 to 3 of f of t dt. And looking from 2 to 3, you have another trapezoid, negative 1/2 times 1 times 2 plus 3 is negative 2.5. And all these values are coming from your graph. And I don't know why I put a parentheses there. It's not necessary. We know for G of 3, when the bounds are the same on the top and the bottom, our value is 0. All right, so now we're going to look at G of 4, and this is going to be our first one that is positive in that the bounds are in the right place. So looking on your graph from 3 to 4, you have a trapezoid, 1/2 times 1 times 3 plus 4, and that equals 3.5. Last one we'll do together, and then I'll give you guys a chance to pause your video, work out the rest, and then see your answers. We have G of 5 is the integral from 3 to 5 of f of t dt. And I'm going to use the accumulation function here. I'm going to use the prior function plus the integral from 4 to 5, which is going to give me 3.5 plus that trapezoid 1/2 times 1 times 2 plus 4, which is 6.5. So if you want to pause your video and work 6 through 10, you are welcome to do so. Six is 7.5, 7 is 7, 8 is 4.5, and 10 is 1.5. So you may want to make just a note of those, pause your video, and we're going to fill in our chart. So we have 0, negative 4.5. We have 1, negative 4, 2, negative 2.5, 3, 0, 4, 3.5, 5, 6.5. I skipped 6, sorry. 6 is 7.5. 7 is 7. 8 is 4.5. And 10 is 1.5. So now we need to take our values and complete our problem. So to find the total change, we're going to do f of 10 minus f of 0 like last time. So 1.5 minus negative 4.5. This change is also 6. The maximum value of g, your highest value of g, is 7.5. This occurs when x is 6. And the range is from negative 4.5 to 7.5. So we should expect to see that when we graph these points on our graph here at the top in green. Zero, negative 4.5, 1, negative 4, 2, negative 2.5, 3, 0, 4, 3.5, 5, 6.5, 6, 7.5, 7, 7, 8, 4.5, and 10, 1.5. This is a mistake. I can see if I can white that out. And then just connect your green dots. And label it g of x. We're going to continue to talk about these graphs here on the next page, just some fill-in information of what we have already found. Describe the relationship between all of those values as k takes on different values. All f of x are vertical shifts of each other. Vertical shifts just means they're going to be moving up and down. And what point must lie on the graph of all of them? K0, when the lower bound equals k. Remember, the area from k to k is 0. And as k takes on different values, the functions f of x equals k to x of f of t dt graph as vertical transformations of each other, each containing the particular point k0, which we just talked about. And even though the lower bound changed is f prime of x, yes, that still works. Shown below is the graph of the derivative f of some function f. Assume f of negative 3 is negative 8. Okay, so we're going to do a line here at negative 3. And f of negative 3 equals negative 8. That's given in the problem. So what we're going to do, if this is our graph, from here to here, we're going to subtract our area because it's left. And from here to here, we're going to add our area because it's right. And you'll notice it's been very nice and gone ahead and put those values in for us. So f of 2, be from here to here. So we have our initial value, -8, plus 10, plus 26, and that's going to give us 28. Don't forget that initial value. F of 6. So our last value is 28 minus 8 because it's below the x-axis plus 14 is 34. F of -5. -5 we go in this direction. So -8 minus 18 is -26. So it's your initial value minus your area to the left. So since the area under F is positive on the interval from -3 to -1, we know the graph of capital F must be increasing on this interval. And since the area under F accumulates at an increasing rate, we then look at the second derivative, we know the graph of F must be concave up. The area under F from on -1 to 2, looking at your graph from -1 to 2, -1 to 2 is decreasing. So F must be concave down. Sketch a graph of F, show extrema, inflection points, and horizontal tangents. So when x is -5, look at part C. We have -26. -3, -8 is your initial value. -1 is -8 plus 10, which is 2. 2 is part A, 28. F of 4 is going to be -8 plus 10 plus 26 minus 8. That would be 20. And then part B is 34. So we're going to plot those points here on our graph, connect our dots, and then we'll move on to the next problem. So if you want to pause your video, go ahead and graph those. We'll check your graph in just a second. Here's what your graph should look like. And we're going to move on to our last page. There's just some fill-ins here for us that should hopefully be pretty obvious for you. So what I want us to do is do a little graphical analysis here before we answer our questions. So F is increasing and F is decreasing. Pretty obvious, I hope. The graph is concave up, and then it switches to concave down. And that would be G, because it's our derivative. We have a maximum of F, which is a point of inflection of G. And then here at 8 is a 0 of F, which becomes a max or min of G. Just a little bit of graphical analysis there before we fill in our information. So F is positive from 0 to 8, so both the x-axis. So G is increasing. F changes sign at x equals 8. And we are going from positive to negative, so we have a max. From positive to negative. The graph of G is decreasing where F is negative. Graph of G is decreasing where F is negative, and this occurs when x is greater than 8. Remember, 0 is your endpoint. The graph of F is increasing from 0 to 4. And we've already said that would be concave up on G. Graph of F is concave down where F is decreasing. We've already labeled that happens when x is greater than 4. So the graph has a maximum at 4, x equals 4, and G has an inflection point there. And again, here's a chart at the bottom where you may want to make some notes. You may want to make sure that you remember this. Hopefully, if something is missing, that will help it click. And I hope you guys have a wonderful day, and I will talk to you soon.